Water swirling down a drain might seem like a simple phenomenon, but it raises an intriguing question. Why does it spin differently in different places? The Coriolis effect often gets the spotlight in this discussion, but does it really play a significant role in how water drains? First, let's break down the basics. The Coriolis effect is a result of the Earth's rotation. It causes moving objects, including air and water, to turn and twist as they travel across the planet. In the northern hemisphere, this effect makes things spin counterclockwise, while in the southern hemisphere, they spin clockwise. It sounds like a solid explanation for the swirling water in your sink, right? But here's the catch. The Coriolis effect is incredibly weak when it comes to small-scale phenomena like water draining in a bathtub or sink. So, what really influences the direction of water as it drains? The answer lies more in the design of the drain itself and the initial motion of the water. Factors like the shape of the basin, the angle of the drain, and even how the water was introduced into the basin all play a much more significant role than the Coriolis effect. For instance, if water is poured into a basin at an angle, it can create a swirling motion that dictates how it will drain, regardless of which hemisphere it's in. Now, let's consider some fun experiments. Picture this. Two identical sinks, one in New York and the other in Sydney. If water is poured into both sinks, they might swirl in different directions, but not because of the Coriolis effect. Instead, it's likely due to the way the water was poured or the slight imperfections in the sink itself. In fact, many scientists argue that the Coriolis effect is negligible in such small systems. It becomes more noticeable in larger systems, like weather patterns or ocean currents, where the scale is massive enough for the Earth's rotation to have a significant impact. So, while it's a fun idea to think about water spiraling down a drain due to the Coriolis effect, the reality is much more mundane. But what about those viral videos showing water spinning in different directions in different hemispheres? They often exaggerate the effect. In reality, the Coriolis effect can only be observed over much larger distances and timescales. It's not something that can be easily demonstrated in a kitchen sink or bathtub. Another interesting point to consider is the role of friction. The interaction between the water and the surface of the drain can also influence the direction of the spin. If the surface is rough or uneven, it can create turbulence that alters the flow of water, leading to unpredictable swirling patterns. So, what's the takeaway? While the Coriolis effect is a fascinating aspect of physics that influences large-scale phenomena, it doesn't significantly affect the way water drains in everyday situations. The direction of the spin is primarily determined by the initial conditions of the water and the design of the drain itself. Next time someone brings up the Coriolis effect in relation to water draining, it's a great opportunity to share this knowledge. It's a classic example of how popular science can sometimes misinterpret or oversimplify complex concepts. In conclusion, the swirling water in drains is a captivating topic that sparks curiosity. While the Coriolis effect does play a role in the grand scheme of things, it's not the main player in the drama of water draining. Instead, it's all about the practical factors at play in our everyday lives. So, the next time a sink or bathtub is draining, remember that it's not the Earth's rotation causing the spin, but rather the unique conditions of the water and the drain itself. Water may be simple, but the science behind it is anything but. Embracing these little mysteries can lead to a deeper appreciation of the world around us. Whether it's the way water drains or the forces that shape our planet, there's always more to discover. So, keep asking questions and exploring the science behind everyday phenomena. Who knows what other fascinating insights await just beneath the surface? And there you have it. The next time someone mentions the Coriolis effect, they'll be armed with the knowledge that it's not the sole reason for the spin of water in drains. Instead, it's a blend of design, initial motion, and a bit of friction that truly dictates the swirling dance of water as it disappears down the drain. DigitalTeFi dives into the world of digital finance, exploring trends, tools, and tips. From crypto insights to tech innovations, this channel keeps viewers informed and engaged. Join the journey to master the digital finance landscape today. Make sure to subscribe on YouTube and other social media platforms.